Start here and just quick talk about what's going to be on the test for Monday or Tuesday. I believe I see you all next week, Tuesday. And we're going to be taking the test in class, which means you're going to show up. We'll talk about just a quick reminder, and then you'll be given about an hour to take this test in class. Actually, 90 minutes. Um, I might have to think about how that's going to work in class, actually. Um, this test shouldn't take more than 45 to 50 minutes. So I think we put an hour and a half just in case you have time uploading your one response. But anyways, so this is a 50-point summative test. There are only 13 questions. 11 of the 13 are multiple choice. One of them is short answer, where you just type the answer, you do the work, and then you type it in. And then there is a 4-part free response question, and we're going to be reviewing that here. And then you have to submit your image that shows all 4 parts. And you're only going to just submit that. And just a quick reminder, when you are submitting images, you have to know first, you have to know how to do that. And some of us still are not figuring that out. And we need to um, find out why. Why are you not able to submit the image? Is it because you're taking a picture with an iPhone and the live photo feature is on, or is there something else that we gotta talk about? But reminder, when you do take that image, the image should be in a well-lit area. I should be able to see it, which means you should check that image to make sure that it's visible to you, because if you can't see it, then I definitely can't see it. Um, and then we're also going to have an extra piece after the test that isn't part of the time limit where you're going to submit all of your work to the entire 13 questions. And that's kind of like my backup piece, but I also use that extra submission as giving you partial credit for some of the multiple choice and short answer questions. So I go back and I look at your work, which means your work for all 13 questions should be work that we've done in class. You should show all of that work, and you shouldn't just have some incoherent numbers scribbled down. If that's the case, then you are not rewarded partial credit um, for the test. So, what are the topics that we have for Unit 3? Well, the biggest one is chain rule. We basically have used the chain rule almost on every derivative that we've taken ever since we've learned it. And that's going to be the case for the entire year. We've learned implicit differentiation. That's finding the dy dx, or sometimes we say find the second derivative. We're going to review all of this today. And then within the implicit differentiation, we were able to find when we had horizontal and vertical tangent lines, and then right equation of tangent lines. Then we had some facts that we learned. We had the derivatives of inverse trig functions, and the only two you're expected to know is sine inverse and tangent inverse. Then we learned the derivatives of the natural log, the regular log, a to the x, and then rational exponents. And I'll show you what that, just to refresh your mind. Give me 1 second. So a quick example here is if I gave you something along the lines of y equals the 5th root of x to the 4th. Could you find the derivative of that? And the the key is do you remember that 5th root is the same as dividing by 5? So you're taking the rational or radical exponent and turning it into a rational exponent, because now you're able to do the power rule, and the derivative is pretty quick. The 4/5 comes down in front, and then we end up subtracting 1 from the top, but that's 5 over 5. So I get 1/5, and that could be my answer right there. Or if it's multiple choice, it's probably written with a positive exponent. So this negative 1/5 is going to come down in the denominator because of the negative, and the 1/5 turns into the 5th root. So that's what we mean by rational exponents right here. And then keep in mind, anything that we've learned from Unit 1 and Unit 2, the product rule, the quotient rule, is a function differentiable? Is it continuous? All of those things are fair game, and we could throw any types of questions in there as well. So here's what we got today. I just want to give you a quick reminder of some things that are coming up, and I think you guys can see my little calendar here. Maybe not. But if we look at today's the 5th, we basically have 2 full weeks of school after this week, and then we've got 2 days before Thanksgiving. So if you count the total days, if you include today, we've got 14 days left of school, which means some of us are in a position where we have missing assignments that, remember, assignments are 50% of your overall grade. So you need to get those in ASAP. And then we also have missing tests, or some of you are able to do the corrections and earn 75% back on those tests. And that's really just open up the test again, do corrections, and email me a photo, and I will give you, assuming you do the corrections correctly and show all your work, I will give you 75% back of your whole test. So that means you can raise your grade up to 75%. Please take advantage of that, but that stuff needs to be done soon. You cannot wait any longer because we only have 14 days left of school. And you have to get that done, submit it, and then give me time to grade it. And all of that needs to be done before the end of the trimester. So look at campus, see what you're missing, check your grade, and just be aware and be on the ball. Don't forget anything, okay? All right, so here's what we got today. In the chat, I'm going to post a link for a Jamboard activity. This is just a slide that you guys can all engage in. And what we're going to do is we're going to go into 8 breakout rooms, which will probably put us at about 3 to 4 people per room. Please, the goal here is to work through about 4 different problems that are going to help you for the test. Please talk through each problem as a group. Talk with one another, okay? You guys are the best resources for one another. And I'd like you to all turn your videos on. I'm going to be jumping in and out of the rooms and just double checking why and how things are going. And then I want you to explain your thinking and make sure like each person is engaged in the learning. So let me just show you the Jamboard quick before I share it with you. So if you're in breakout group 1, you're going to go to slide 1. If you're in breakout group 2, you'll click over to slide 2, and then you're going to type your name, what they ask us to do here. I have a feeling we're going to have a handful of people joining us late because they just got kicked out of the groups. So in problem number 1, they said, here's the displacement. Now, displacement is the same as position. So when we think about position, if we take the derivative of that, that gives us the velocity. So what I have to do is take the derivative of the 2 pieces, the t here, and then the t times ln of t. Now you do have to be really careful with this negative. I didn't realize it right away, so I just left it there, and then I put big grouping symbols, which is going to distribute a negative. But it's the product rule. So the derivative of the first times the second plus the original first times the derivative of the second, which is 1 over t. And then you've got some nice simplification. These reduce out, so I get 1. And then you have to distribute the negative to each piece, and then you end up having 1 minus ln of t minus 1, and the 1's reduce out. So the velocity equation is actually pretty friendly once you get through that product rule. So now that I know the velocity, to find the acceleration, we just take the derivative of that, or that's the second derivative of the original displacement. And then the derivative of ln of t is just 1 over t, and the fact that it's negative from before makes it negative. So number 1 was challenging because you had to get the first part correct to do the second part correct. But if this was a handwritten test, whatever answers you got for part A, if you use them correctly for part B, you could still get the points for part B, which is the nice thing. You don't have to get part A 100% correct to earn full points on B. But what are they asking? They're saying find the velocity at point E. Well, if I take the velocity equation and I plug E in, remember the natural log of E is 1, so the overall answer is -1. And then if I plug in E for acceleration, that's just -1 over E. So make sure you recognize when to use the product rule, and don't be scared by that word displacement. It means position. All right, and then number 2, I was happy to see a lot more groups ended up working through number 2. I do want to focus on work. So let's say that number 2 was a test question, and maybe it was a short answer where you just type it in. Well, what I'm looking for is on your sheet that you're going to submit after the test is done, I'm going to go back and look, did you show this work? Did you show that you had to take the chain rule of f of g to find its derivative? And then did you plug in 5 and did you use the composition of functions correctly? So g of 5 is 1, that's the red 1, and that's where we got the information from the table. So g of regular 5 is 1. And then g prime of 5 is 3, and f prime of 1 is -4. So 3 times -4 is -12. And by the way, these are going to be on Schoology, so if you want to go back later on tonight and study them, you can. And then K was just a create more intense chain rule. Now notice for part B, we had to find the derivative of the outside function first. That's just g. And then the inside function happens to be just a polynomial, f of x plus 3x. So I'm going to take the derivative of the outside, which is g prime. We're going to keep the inside, and then I'm going to multiply by the derivative of the inside, which is f prime 3. So there's the chain rule. And then all we have to do is plug 1 in and evaluate each piece as we go along. And it's using the table. So you can see that we have f of 1, which is 2. 3 times 1 is 3, so that gives me 5 on the inside part, but I still haven't done g prime, so I'll do g prime of 5 from the table. And then over on this side, we've got f prime of 1, which is -4 from the table, plus 3 gives me -1, and my overall answer should be -3. Okay, so again, you'll be able to go back through and check your work. I would like to work through one problem here together, and then we're going to talk about the quiz that you guys took last Friday, Saturday, Sunday. It was due Sunday night. Some of you didn't even take it yet. But I will basically share with you in some form, you will have these questions on the test on Monday or Tuesday. Not exactly the same, but you're going to have to show, I'll give you a function that has x's and y's, and you have to do implicit differentiation to show that this is the derivative. And you have to do that on your quiz as well. And then you will be asked to find when you have horizontal tangents, if possible. They don't always have to be possible. And then maybe even vertical tangents. We'll talk about both of those. And then write an equation of a tangent line and find the second derivative. So this is a good review for us to work through. And what I'd like to do is go through this kind of step by step here. So I'd like you to work, and I'm going to give you like a minute to get this done, and we want to kind of focus on time too. So find the derivative of the first part and show that it looks just like the second part. Why don't you go ahead and do that? All right, let's go over this quick. So what do we have to do? We have to take the derivative of both sides. Well, the first part is x times y. That's the product rule. And if you want, you can do your side work and say, here's u, here's v, but I don't think we need to. Because the derivative of the first is just dx, or you could put 1. And then it's times the original second, which is y, plus the original first, which is x, times the derivative of y. So there's the product rule. I hope you're very comfortable with that. And then I have to take the derivative of the right-hand side. Well, the derivative of 2y, now notice, every time you take the derivative of y, you have to have the dy dx. If you don't put that, you're missing out a big piece. And then the derivative of 3 is 0, so I don't need to put that. Dx reduces down to 1. But dy dx doesn't. And then what I have to do is I have to move the dy dx's over to the other side. So I'm going to take this x dy dx, and we're going to move it over to the other side with subtraction, which means what's left over? Well, on the right or the left-hand side, I'm left with y. And then over here, notice how I have a 2, and that has a dy dx, and then I'm going to subtract the x over to the other side, and that has a dy dx. So I'm going to do kind of 2 steps in one and just move the x over, but factor out the dy dx at the same time. And I showed that dy dx looks exactly what they wanted it to. Now there is one thing that I noticed on the quiz that I just want to quick mention. What if you moved everything over to the other side? What if I moved the y over here and the 2 over here? If I did that, then things would be flipped around and it would look like this. So you don't have to write this part, but my answer would be exactly the same but negative. Well, one thing you can do from everything, you can always factor out a negative 1 over 1. If I take away a negative 1 over 1, well, notice nothing happens. It just takes away a negative from each piece. So on the quiz that you guys took, some of you had you had exactly what it was, but all the signs were opposite, and all you needed to do was just basically take out a negative 1 from each factor, and you're left with the original. Whoops, I don't know why I flipped this upside down. Sorry, that the y should be on top. I don't know what I was thinking there, but hopefully that makes sense. Is if you get exactly this, but opposite signs, you can automatically factor out that. Okay, so now what are we going to do? Well, now we want to figure out in part two, does this curve, which by the way, they gave you the answer, so you should always refer to their answer if yours is different, but does this curve have any horizontal tangents? Well, what do we need to know? If it has a horizontal tangent, that's when the derivative is equal to zero. We're not plugging in zero. We're saying that this whole derivative is equal to zero. So I'm going to give you a minute to solve this and see what you get. All right, so let's take a look. So dy dx has to be equal to zero. Well, if I take the derivative and set it equal to zero, I can always put this over 1. And then you're really just cross multiplying. 1 times y is y, and 0 times anything is 0. But we have to be very careful. Notice it says if so. Does it have any? Well, yeah, and apparently it has one at y equals 0, but if that's the case, then we have to find x. And when you find x, you go back to the original equation. And you have to plug in y equals 0, and you should get an answer for x. This is kind of like dealing with a system of equations, but we run into a problem. I get the right side being 3 and the left side is 0. I don't have an x, which means 0 does not equal 3, so therefore there are no horizontal tangents. If I got an answer like x equals 5, then I would have one horizontal tangent at the spot 5 comma 0. So if an x or sometimes two x's appear, um, just be aware. But if you check your answer and it doesn't work, then that means that there are no horizontal tangents. All right, this is a big one, part 3. So I'll give you another minute to work on this. Okay, so let's take a look here. It says, write the equation of the tangent line. As soon as you see those directions, you should ask yourself, okay, what do I need? I need a point, which they give it to me. By the way, if they only give me an x or a y, let's say they said they only give me y equals 2, you can go back to the original equation, plug 2 in, and you'll be able to find x. So we only have to give you one of the points, and you can always find the other point. But in this case, they gave us both. So that's x1, y1, and those are going to go in the two spots for the equation of the tangent line. And then I need the slope, and this is the reason why we do this problem. Slope is the derivative, which we already know. But it's the derivative at the point 3, 2. So then all I have to do is take this derivative of y over 2 minus 1, or 2 minus x, and I'm going to plug in a 2 for the y and a 3 for the 1. And then I'll just simplify. This becomes 2 over negative 1, or the slope at that point is negative 2. And technically, I would say stop here. You don't get any extra points for distributing and solving. The only time you'd need to do that is if it was multiple choice. All right, the last piece, and this is the big one that I think we still need practice on this one. So we're going to do this one together. I just want to make sure everybody's aware. I'm asked to find the second derivative, but they've given me the first derivative. So I just have to take the derivative of this answer. Well, that's a quotient rule. So if I take the derivative of both sides, notice d times dy gives me d squared y. Dx squared that's where we get this notation from. And then to do the left side, or the right side, it's the quotient rule. Now, again, you don't have to do this part. You don't have to show any work for this. If you can do the quotient rule in your head and write the answer here, then you're in a good spot. If not, let's come up here and say, all right, what is u and what is v? And then I have to take the derivative of each piece. So notice the derivative of u is dy dx. The derivative of v is negative 1. Now, I could write dx dx here, but we know that that dx dx is just going to go away. All right, so what is the quotient rule? This should be something you have memorized. I'm going to erase this part, but it's the derivative of the first times the second minus the first times the derivative of the second, all over the original second one squared. So this is what we're going to apply right here for the second derivative. So it's the derivative of the first, which is dy dx. That's really important. Times the original second, which is 2 minus x. And then we're going to subtract the original first times the derivative of the second. So y times, now the dx reduces out, so the only thing that's left over is a negative 1. And then that's all over the original v, or denominator, squared. Now, you're almost done, but look at right here. It says dy dx. We can't write a derivative, or the directions actually are going to be more specific. The directions are going to say write the second derivative in terms of x and y only, which means you can't have dy dx in there. But wait a minute, don't we know what dy dx is? It's right here. dy dx is y over 2 minus x. So we're just gonna replace that. Instead of writing dy dx right here, we're going to replace it with what dy dx is. And remember, they gave that to us, right? That was what number 1 was already telling us. So we know that dy dx is equal to it from earlier in the problem. So I'm just going to finish this one off. I'm going to replace dy dx with y over 2 minus x. And then this last part, negative y times 1 is a positive y. And then the bottom part, I would just leave as is. Now, you don't get any extra points for distributing and trying to simplify, so you could leave it like this. However, notice how this could be written as 2 minus x over 1. And if instead of distributing, I could reduce out a 2 minus x on top and on bottom. So if this was a multiple choice question, it would most likely be written as a y plus another y. So it would be 2y over 2 minus x squared. So there is some algebra that's actually quick to reduce, but if it's a free response question, stop right here. Don't go further than that. Okay, so I hope you can confidently check off all 4 of these problems, because I'll guarantee you're going to see them on Monday or Tuesday, right? Find the derivative. When do we have horizontal tangents? And write the equation of a tangent line. And remember, anytime you're finding slope, slope means derivative, but it's the derivative at the point that they give you, so you have to plug the numbers into the derivative to figure out the actual number or that slope. All right, so here's what I want to just quick go through. Some students are asking, how do we get points back on this quiz? And since I had to hand grade some, I'm going to go through a couple questions right now. Don't write this, but if you want points back on your quiz, all you have to do is take a separate sheet of paper, go back to the quiz and open it up, and then correct the ones you got wrong. But I want to talk about a couple problems just quick. So notice, what is the slope of the tangent line? So you need to define dy dx, and then you have to plug in x equals pi. So whatever the derivative is here, don't forget you've got a dy dx here. There's a chain rule right here. Actually, this is a product rule too. So this one's pretty heavy. You got a product rule and you got x's and y's mixed together. I'm not going to go through it mostly because of time, but you find the derivative and then plug in pi and it should simplify down. This one, find the derivative implicitly. Notice you have a product rule right here. So we just kind of went over one like this, but you're going to have dy's, dx's, so you got to find the derivative and then move all the dy dx's over one side. Here's the thing. This problem is a little tricky. The answer was A, C, and D. So I actually gave you full credit if you said the answer was A, C, or D. I gave you full credit, but know that any algebraic manipulation of these is also possible. And I just thought that was too tricky of a quiz, so I did give you full credit if you answered any one of those. If you answered B, I didn't give you credit for that. Same thing here. Actually, this one, I wanted to apologize for this one. This one is wrong. The answer isn't even possible. It's not even on here. Something did not translate well when we created the quiz. So I gave everybody full credit for this problem right here because it was not on there. This is just like what we talked about before. If you have dy dx, you have to do substitution and plug it back in. So don't worry about that problem, but it is a good problem. And these were the questions that students had where you had to submit your work. So this was confirm that the derivative looks like this. And some of you had very similar pieces, but it's just you didn't reduce out a common factor. And when you reduce, you can get that same answer. But notice there's a product rule right here. So the product rule appears quite often. All right, this was the part I wanted to talk about just quick. So here's a function, and it says identify when the graph is horizontal tangent lines. Well, horizontal tangent lines are when the derivative is equal to 0. And then in this case, they just wanted one x or one y. Vertical tangents are when the derivative is undefined. Well, if something is undefined and it's a fraction, what do? We set the denominator of dy dx. So take the derivative and set the denominator equal to 0. So it's what makes it undefined, and that's how we do vertical tangents. So just be aware of that. And I'll let you in on a little secret. Remember the other day we did the inverse functions where we had like f and g of x? That is not going to be on our test. We introduced it. We decided it's not fair we only spent a little bit of time on it. So here's what we got tonight. All right. Your homework tonight is a Kahoot review. It is on Schoology, so you'll be able to, let me see if I can pull this up here. You'll be able to find it right here under the Thursday folder. There's a link to the Kahoot review. You need to show your work on a separate sheet of paper and then submit your written out work to Schoology. That's the assignment tonight. And then I also put an optional review worksheet. If you want more practice for this test, you can click on this worksheet and work through it. I will post the answers to the review coming up as soon as I finish it. I just got it last night, so I got to finish it and post that. But that'll give you something to look at over the weekend. And the Kahoot answers are in our answer folder as well. So when you're done, you can check. All right, that's all I got. I will be in my office hours today from 1 to 2 if you have any questions. And remember, our test on Unit 3 is next week, Tuesday, in class. So have a great day. I hope you're feeling confident for the test. Good luck. All right, Tree, how you doing? Any questions? All right, so Tree, if there's no questions, I got to jump to my other class here. So have a good day. We will see you Tuesday.